Okay, I'm going to do two examples for you of graphing by hand. I've already shown you how to graph in the calculator, and I'm going to do these two examples for solving a system graphing by hand. It's a little bit hard to do on this screen, so I'll do the best that I can and hope that the things that I was able to show you before I left, you'll be able to refer back to those. Now remember, when you're graphing, you always have to get everything in y equals. It has to be in y equals so you can graph it. So I'm going to start with this one right here, and I'm going to get it in y equals. I'm going to begin by moving the x over to the other side. Okay, so that's going to give us negative 3y is equal to, moving the x over gives us negative x, and the 6 doesn't move, so that's plus 6. Now then, the next thing I have to do is to divide everything by negative 3 so I can get the y by itself. Those cancel, and that gives me y equals. Those two negatives cancel and give you a positive, and I'm going to put the 1/3. There's an understood 1 in front of that x, so I'm going to put it like that. And then 6 divided by negative 3 is negative 2. So that's the first equation that I'll graph. I'm going to do that by starting my graph. My y-intercept is at negative 2. Okay, there's my point. And then I'm going to rise 1 and run 3. And that puts a point right there. Okay, and then we can go up 1 and over 3 again and put a point right there. Okay, so there's 3 points, and we can draw a line through it. And you really, really, really need to use a straight edge, because as you can see, if you're not using a straight edge, it's not going to be a very good line. So my line's not great, but we do the best we can without me being able to show you with a ruler. Okay, now we're going to get this one in y equals. We'll draw a little line here so it's separated. So I'm going to move the x over. That's negative 3y is equal to negative x minus 3. That x right there is minus. Then I'm going to divide everything by negative 3. Okay, these cancel and I get y is equal to, now see there's that negative right there, so that's a positive 1/3 x plus 1. Okay, now when you look at those, I want you to notice the slope of this line is 1/3 and the slope of this line is 1/3. That tells you you have parallel lines, so you are not going to have a solution, but you're going to go ahead and graph it. You want to go ahead and graph it. That way you can see where the parallel lines go right side by side and never touch. So we're going to start at positive 1. Okay, and then we're going to go up 1, over 3. Okay, and you can see it's very, very hard on this thing to graph. Okay, so there's your lines going right side by side and never touching. So down here you would put no solution, because the lines are parallel. Once you get them into y-intercept form, you can tell they've got the same slope, so they're not going to. So there's no solution. That is an inconsistent system. Inconsistent system. Inconsistent. All right, so that's one case, and that's how you graph those. Now we're going to graph the next one. Okay, so let's pull that picture up again. Okay, and I'm going to move that up, and we're going to do this one right here. Okay, so we're going to start and get this into y-intercept form right here. I'm going to do this first one. Okay, so that's going to be negative y is equal to, moving the 2x over makes it negative 2x plus 1. And then I change all the signs because my y is negative, so I'm multiplying everything through by negative 1. And there's my first line. And I will graph that starting at negative 1. Okay. And then I'm going to go up 2 over 1. This one's pretty steep. Okay, that's kind of hard to see, but that's going to be my line. Okay, so there's that line. Then I'm going to get this one in y-intercept form, and I box that off where you can see. I'm going to start off by moving the 6x over. It becomes negative 6x plus 3. Then I'm going to divide everything by negative 3. That gives me y is equal to, that's negative 6 divided by negative 3, which is positive 2x. And then 3 divided by negative 3 is negative 1. Again, what do we have? The exact same line, not parallel, but the exact same line. Look at your equations. See how they're exactly the same? So it would just be one on top of the other. There it is again. So all solutions, these are coinciding. Okay? Coinciding all solutions. Coinciding all solutions. And that is a dependent system. Dependent. Okay? So that's two things that can happen. You can have parallel like we did in the first one. You can have coinciding like we did on the second one. And then you can have intersecting, which we have not done an intersecting on the graph yet. Okay, now then, if you'll look at this problem, this is going to be the last one that we're going to graph. Again, be sure you're in y equals. Once you're in y equals, then you just plot the points, plot the graph, and see where the lines intersect. This one is already in y equals, so we could go ahead and graph it. Okay, it's going to start right here at 1. Okay, then we've got a negative slope, so you could go down 2 and over 1. Down 2 and over 1. You could keep doing that over and over as many times as you need to get a good line. Or you could go up 2 and left 1. All of those things are okay. Okay, so we're going to try to draw a straight line through there. Okay, that's not a great line. Hoping we intersect well. Okay, now then, this line right here, we're going to get into y equals. So to do that, we've got to move the x over. So that becomes negative x plus 3. Now notice your slopes are different. You've got a slope of negative 2 for this one and a slope of negative 1 here. So these lines should just intersect. We're going to start right here on this one at 3. That's our y-intercept. It's got a negative slope. So I'm going to go down 1, right 1, and put a point. And down 1, right 1. And as you can see, I'm having a little bit of trouble with that. And then you would just continue. Here I'm going to go up 1, left 1, up 1, left 1, and it looks like they're going to intersect right there, but since I didn't draw my line very straight, it's kind of hard to tell. As you guys are doing this, be sure that you're using a ruler. Okay, so there we go. Okay, and it looks like an intersection at -2, 5. Circle your intersection. Check me on my lines being straight, but it looks like that the intersection is at -2, 5. We could solve that algebraically and make sure. But that's how you solve graphing. You can do that in the calculator and you can do it by hand. So we need to be able to be sure we can do it both ways. All right, now you'll do an assignment on graphing. And the name of the paper, it's A number 1-1, Solving Systems of Equations by Graphing.